So here we want to find all the points of inflection given the function f of x equals cosine 2x. Well, points of inflection we get from the second derivative. So first, let's start by finding out what the first derivative would be here. So in this case, f prime of x is equal to derivative of cosine is negative sine 2x times the derivative of the inside, which is 2. So we can simplify that to negative 2 sine 2x equals f prime of x. And now we want to take the second derivative, so f double prime of x equals negative 2, derivative of sine becomes cosine 2x, times the derivative of the inside, so times 2. So f double prime of x equals negative 4 cosine 2x. So now to find the points of inflection, also I should state this is on the interval from 0 to 2 pi. So to find the points of inflection here, we simply set our second derivative equal to 0. So 0 equals negative 4 cosine 2x, and we solve this. So divide by negative 4, divide by negative 4. 0 equals cosine 2x. So we want to figure out, well, where does cosine 2x equal 0? Well, I would graph this out here. So I'm going to go ahead and draw my graph. We'll let that be 1, negative 1. Cosine 2x, that tells me the frequency here is 2. So the frequency is 2, meaning I have 2 cosine curves in 360 degrees, which is 2 pi. So cosine, I know, goes like this, down, up. So there would be 1. So right here would be 180 or pi degrees. And then back down and back up. And then finally this would be 2 pi right here. So 2 pi. And then right here we'd have 3 pi over 2. And this would be pi over 2. Okay, so this is what the cosine of 2x looks like from 0 to 2 pi. So we want to know, when does that equal 0? Well, it equals 0 right at this point, it equals 0 at this point, it equals 0 at this point, and it equals 0 at that point right there. So this first point right here is halfway between 0 and pi over 2, so that would be pi over 4. This point right here, halfway between pi over 2 and pi, so we get 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So it equals 0 at every one of those points there. Okay, so every one of those points. And then you could even run your test if you want to. If you put all of those on your line here, you can see what kind of concavity do we have from here to here. That would be concave down. Then from here to here is concave up. Then from here to here, concave down, concave up, concave down. So these are all indeed points of inflection. Okay, so it's where they're switching from concave down to concave up, or concave up to concave down. So it'd be x equals all of these. So x equals that, x equals that, x equals that, and x equals that. So there are all your answers.